Good morning, everyone. This is Abhishek Yadav, cohort of B, Department of Cloud Computing, and this is the video demonstration of my final year's thesis, which is the real time inventory optimization using AWS Lambda and Kinesis. So the introduction start with the information which we have collected that the in nowadays the data is everlasting growing, and the company needs to order manage their stock in a longer run period of time. So every day the data is seamlessly growing, and the requirement of handling this data can be a little bit costly for the companies and organization. So we are here to find about that what are the approaches we can take in order to manage this data. So the problem statement begins with the how can real-time inventory optimization using AWS Lambda, SageMaker, and Kinesis predict the efficiency and accuracy of inventory management. So basically, we will developing a solutions in order to find out that how we can integrate different AWS services in order to find about the inventory prediction, whether the data is going to be whether the stock will be going overstock or understock situation, which and what are the cost based on that what are the cost will be charges in order to like reach that optimal performance. So this evaluation is for scalability and flexibility and availability to handle multiple requests based on the given demand. So before starting this project, we have go through some of the paper in which we are able to analyze that what are the services and what are the tools previous researchers has been done in order to integrate the similar kinds of approach. However, we able to rectify that in some of them they were lack to present that how integrating the AWS Lambda machine learning and different services will if affect the scalability, and what are the costs associated particularly for like integrating them and running them seamlessly. So based on that, we are presenting our solution. We What we are doing, we are able to integrate different services, and then we will analyze them the services performance in the cloud watch, and then we will rectify what are the costs associated with them while running into a 1 month period of time. So this is the architecture diagram of our implementation. So first we will start with the raw data. We collected the historical data from the Kaggle, and we will train our machine learning model based on that the given historical data in order to predict the overstock and understock situation while running a multiple hits and request on a database. So this stage maker will we will implement the machine learning model and train them, and then we will perform the endpoint with our lambda function. The lambda function will able to analyze the given data, and the whichever the data is coming from the kinesis which is going to be hit by the user is to trigger the lambda function, and the function will first analyze whether the data is supposed to be in a proper chronological order or not. If it is not, then it's going to be discard the data, and if the data is a suitable to it's suitable to analyze, then it will perform the trigger function, and then it will perform the rewrite on our database, and the similar the performance of the result will going to be logged inside our CloudWatch, and then the user will get the notification of whether the stock will be go on overstock or understock, and based on the all utilities it will get the CPU a trigger alarm that how much CPUs are using in order to utilizing all their inventory management and the prediction. And all this data can be visualized in the stage in a quick set in order to visual representation and easier for user to understand. So as I explained my architecture diagram, so now we are moving to the practical implementation part where I'm going to be running this all to check the overstock and understock situation. So this is the code of the Jupyter Pi, which we have trained our machine learning model, and it's giving the forecasting of value of 66% of accuracy. and the basic forecast will give you the historical data. We are taking the S3 bucket, where we have saved our data set in our S3 bucket, where it is getting the data, the historical data, and forecasting the value inside, forecasting the value for machine learning, and check the situation in a alert function. So this is the Lambda code. This is the Lambda function. We have connected the Kinesis to our Lambda in order to first check whether the streaming data is getting whether the streaming data which we are performing is in proper order of format or not. So I have already run this code. So it's saying the succeed, which means the given current data inside our system is in a correct format. So now this is the function for checking the overstock and understock situation, which is connected endpoint with our machine learning algorithm. So this is the frame which we have defined for the overstock and understock situation. Like if the threshold will reach to a minimum 50 or less, it will take a minimum threshold. If it's the over than 300 is maximum, and the 100 record and below its level, it's considered an error point. Now now this is the CloudWatch integration with our Lambda function. Whatever the record and whatever the trigger we will get, it is going to be performing, it's going to be demonstrate in our CloudWatch environment. So this is our DynamoDB table. So currently we have a threshold of a 300 user data set. So now I'm going to be performing the understock situation, where I will forcefully delete the data. So I have already connect my S3 with my local terminal. So let me first take and forcefully delete some of the data. So here is the code, and now as you can see, as you can see as you can see, the data is getting deleted. It is deleted over a period of time. So this is the data which has been already created, but it is now going to be deleting in gradually as 464, 441. So this is the way the data has been deleting. And since we have already set an alarm, so for this, so this is the understock alarm of function. So we have analyzed that over one period of time, this is the threshold, where if it cross the particular threshold, it will hit the alarm, and it will generate a message in every 6 hours. So this is the one notification of my CPU alarm. So as per running the entire as per running the machine learning algorithm, so how much ever the CPU has been utilized, it's going to demonstrating in a graphical format that how much CPU utilization has been done. So we can choose the custom matrix, and we can see that in a 3 weeks period of time how much heat it has been reached. And then it will generate the data, generate the notification email to remind the user that the CPU alarm has been triggered, that your utilization has increased. So you have to either reduce the stock data, or stop the functionality, or stop the functionality of machine learning. Now Now as you can see, we have deleted almost all our data, so it's still currently still deleting. So in understock situation, it is also same generating the mail. So I have already triggered some of the alarm. So in the period of time, it will take it will generate the situation like this in understock. It will generate the mail of cpu alarm that your data has been reduced significantly and could cause the understock situation which you have to handle. So this is the way the user will get the notification of the stock, whether it's whether it is going to be overstock or understock or not. So based on this, we have implemented a lambda function. So for the utilization of triggering entire thing, that whatever the cpu utilization for the analyzing the data inside our inventory management, this is the presentation of the lambda function, which is going to analyze and give the trigger that how many time our lambda function has been hit and cross the particular threshold. So this hit also get the notification for the user, something like this. So this is the lambda hit which I presented, like whatever the lambda utilization for analyzing the data. If it utilizing too much CPU ec2 instance, then it will hit the particular threshold and give the information to the user that the functionality has been hit to its maximum reach level. So this is from my side. So based on our implementation, we got the total $62 of charges for a 1 month period of hit time. As you can see, the stage maker got the most amount of hit because it's using the machine learning and the CPU utilization in order to predict the data whether it's going to be overstock or understock. And then since it is a free tier account, some of the services are showing $0. Now, come to the limitation part. This is the database variation limitation. The the paper which we have, the thesis which we have conducted, it's having some limitation where we have a limitation of variation of data. And because the other papers have a profound the more variation on the data set, so it can be a trigger for getting a most optimal result. The base paper is generalizes methodology uh, based on multiple scenario where we have defined in overstock and understock situation, and we able to reach this optimal result successfully, that how our data is going to be performed. And then in the given time frame, we have a limited time frame for the running the uh, test cases. So our learning curve is little bit shorter compared to the other paper which we have go through and analyze them. And the cost optimization is limited to our free tier account. So if the data has been increased gradually in a longer period of time, it can be a situation where the effective solution can be redundant. So these are the references, and thank you. That's it from my side.